Hi everyone. Let's talk about Newton's three laws, his three laws of motion. The first law is oftentimes called the law of inertia. This states that an object at rest wants to stay at rest, or it also means that an object that's already in motion tends to stay in motion, and that motion continues in a straight line at a constant speed. It's called the law of inertia because inertia is the property of matter to resist changes of motion. And so that's what it says, is that Newton's first law is, once it's in motion, stays in motion, or if it's at rest, wants to stay at rest. A good example might be the old magician's trick where there's a big stack of dishes on a table and the magician pulls the tablecloth out from under it and the dishes remain in place. And that works because the dishes have inertia. They don't want to change their speed. They are at rest on the table. And if you pull that tablecloth out quickly enough without allowing much friction to exert a force on those dishes, well, the dishes should just stay in place. Newton's second law is called the law of acceleration. And it simply states that if there is a net force acting on an object, the object will accelerate. Well, remember, acceleration is the rate of change of velocity, and velocity is speed and direction. So this says that if there's a net force, which means that the forces are not canceling out, there's some net force, they all add up and push the object in a certain direction, then that object is going to speed up in that direction. And importantly, the acceleration is directly proportional to force. That is, the harder you push on it, the more force there is, the more acceleration there is, the more that the velocity will change. However, acceleration is inversely proportional to mass. And that means that the more massive the object, the more it's going to resist change, the less it's going to accelerate. And again, mass is a measure of inertia. So, second law kind of ties into the first law. Let's see, you should also be aware of a little bit of algebra. This law says that acceleration is directly proportional to force. So, sort of like acceleration, A equals force F. More force, more acceleration. But it's inversely proportional to mass. Okay, so mass is inversely proportional to acceleration, and that means that the bigger the number for mass, the smaller the number for A, acceleration. And maybe it'd be easier just to illustrate with some fractions. If we look at the 2 and we compare 1/2 to 1/4, well, 4 is bigger than 2, so the denominator is getting bigger, but the whole thing, the fraction, is getting smaller, right? 1/10, 1/100th, 1/1000th, whatever. As the denominator gets bigger, the whole fraction gets smaller. That's inversely proportional. And I like this little illustration down here. You got the big, massive elephant here with huge mass, and this poor little guy is trying to exert a force, but he's kind of small. There's some roller skates on the elephant here, trying to neglect friction. So just ignore friction. And how fast will that elephant pick up new speed? Well, acceleration is proportional to force, which isn't very much. It's inversely proportional to mass. So it's going to start changing its speed. It will start moving as long as this guy doesn't give up. But it's going to be a pretty slow increase in speed because the mass is so big. The third Newton's law, this is the law of action-reaction. And this states that for every action, there's an equal and opposite reaction. Or more specifically, the way the book describes is whenever one object exerts a force on a second object, well, that second object exerts an equal and opposite force back on the first object. Got a couple illustrations here. We got this, looks like a sailor firing a rifle, and the action is that the bullet comes flying out, and the reaction is that there's a recoil. The gun kicks back. And so what's happening here? Well, you got the gunpowder that explodes and starts pushing on the bullet, So inside the barrel here in the chamber, you got the explosion taking place. It creates gas and pushes the bullet out. And so that's the force on the bullet pushing it out. But then the bullet has inertia. It was at rest, doesn't want to change its motion. So it's going to resist that change and push back on the gas. All the gases get pushed back against the back end of the barrel, and they push on the rifle, which in turn pushes on the man and knocks him down. The amount of force that the bullet experiences flying out is really great, and that same amount of force, but in the opposite direction, ultimately pushes back on the man and knocks him down. Here's another illustration over here. You got this man, he's got some weight. Gravity is pulling him down towards Earth, and he's not sinking into the ground. No, he's at rest because there's a support force. And I should get these arrows same height because the magnitude of the force, the strength, the size of the force is the same. The man's being pulled down by gravity and being pushed up by the ground in equal and opposite directions. This third law, the law of action-reaction, is perhaps the most difficult to kind of understand. In fact, I was reading the book that Newton himself had trouble with this law. And so I got another video coming up soon that kind of breaks this down in a little more detail so we can understand it. Thanks for watching.